And here we go. Welcome, everybody. Welcome to this presentation about the integration of NGINX App Protect in your DevOps workflow. My name is Adrian Kosmaczewski. I'm in charge of developer relations at the VSHN, the DevOps company, and I'll be your host tonight. Joining me, together with me tonight, are Arno Auki and Sergio Nuzzo from VSHN, and also Mario Klima from F5. They are here with me tonight as well. Just a few words about VSHN. So the first thing you have to know about VSHN is how to pronounce the name. It's called VSHN, that's why you have an I in the logo, of course. We are the DevOps company. We've been since 2014 in Zurich. We are 40 VSHNeers, as we call ourselves. We're the leading provider of cloud services and maintenance and 24/7 operations for our customers, particularly in the Kubernetes world in Switzerland. And we are certified in various different ways, which are very convenient for some of our customers. And we also hold the title of the first company to have been certified Kubernetes certified provider in 2016. We work with plenty of big names in the cloud native space. I'm pretty sure you know pretty much all the logos here. However, of course, tonight we're going to be talking about the NGINX and F5, of course, because it's the company that is behind NGINX right now, and they are here with us, so that's great. One more thing, we at VSHN, we do as well our fair share of open source and products. So on the product side, we've got our own platform as a service called Apuyo, which you are very welcome to try. And of course, we have our own project in open source in GitHub, namely Project Syn and KDAP. Project Syn is a tool we are building to manage a fleet of Kubernetes clusters wherever they are in the world. And KDAP is the tool we use every day to solve the problems of backups for our customers. So these two projects are completely open source. Feel free to check them out. They are all in GitHub. Very good. So what's the agenda for today? Because you haven't joined to learn everything about VSHN, although we're very happy to tell you about us. First of all, we're going to talk a little bit about how the whole DevOps thing is moving into DevSecOps. We're going to see how NGINX App Protect is able to help us in our day-to-day job here in VSHN to help our customers provide more security for their applications. We're going to see a small demo. So I'm praying for the demo gods that everything works, because everything will be live. We're going to be deploying NGINX App Protect on Kubernetes cluster tonight. So let's cross our fingers. At least I'm crossing mine. You don't see my hands. Basically, we're going to have some question and answers, of course. So please, if you have any questions, there's a Q&A box on the bottom of your Zoom window. Feel free to pose your questions there. My teammates will be checking it out and will probably answer some on the go. If not, we're going to answer them at the end. Thankfully, we also have the help from F5 who's attending. So maybe if you have some questions about, very deep questions about NGINX, don't hesitate to ask them. We are very happy that you're here in any case. So let us start with the whole DevOps thing, because I don't know if you've seen in the news, but there were long queues of people in the United States queuing to get gas for their cars, right? And why did that happen? Well, actually, it was ransomware that basically broke down a whole pipeline. And that shows the level of threats we have in the world of today. It's something you can see in the news every day. More and more is happening more and more often, unfortunately. So it's very important. I know that you know this, but I prefer to stress this fact. And let us begin with the whole DevOps thing. So if we look at the history of enterprise computing, of course, we went from very big applications that took years to be built, cost millions of dollars, and a failure in the development of one of those apps would bring the whole company down in bankruptcy. As we move to the present day, we see that the cost of the solutions we are delivering is every time lower, and the risk of these things is lower in terms of what would it cost if the feature is not released. However, the cost is still high and it's growing in terms of security. And DevOps is here to provide a framework on top of Agile so that cloud native teams are able to deliver their applications to the world. DevOps is a philosophy more than a methodology. So basically it consists of three basic ways, three principles, as Jim Kim puts it very well. The first principle is the principle of flow, which allows work and features and fixes to go from development to operations without interruptions, building quality in and optimizing every step of the way. Then you've got the principle of feedback. Developer teams get feedback from users, from operation teams, and so on, to be able to make the product better and faster and with less bugs at every iteration. And then we have the principle of continual learning and experimentation. This requires a culture of no blame. So basically people feel free and comfortable and secure to try new things and to experiment. All of these three principles have been exposed in a series of books, which most probably you've heard about, but I'm just mentioning right here, these are the basic books of DevOps, if you want, the DevOps Handbook and the Phoenix Project. The Phoenix Project itself being a rewriting of the Goal by Eliyahu Goldratt in the 80s, and then the Unicorn Project is the second part of the Phoenix Project. They are all very good, and this picture is mine, actually. I have them at home, and I like them very much. One of the base tenets of DevOps is infrastructure as code. So DevOps teams store the configuration of all of their infrastructure in text files. Here, for example, you see an example. This is a Terraform configuration file that describes precisely the exascale Kubernetes cluster running on exascale that I'm going to use tonight. So as you can see, it's running on the Switzerland Geneva zone, and basically it's a cluster named demo, and there's a couple of security rules, and there's a node group, so basically we can have some virtual machines attached to the cluster, and everything is configured for us. But all of this is written on a text file. It's a very simple thing. It's very conceptually very obvious, and teams can integrate this into GitOps, because if it's text, I can version it. And if I can version it, I can put it in Git, because everybody's using Git these days. There's very few teams using Mercurial, but you can do Mercurial ops. You could do actually even Subversion ops, but most of the people are calling this GitOps. And in the screen here, I'm showing GitLab. GitLab has a tremendously good CI/CD pipeline system, which I'm going to be using tonight as well, that basically allows you to integrate all of these pieces together so that every time that I make a change on my infrastructure, I add, typically, for example, I add a new node for one of my customers. They want to have more capacity, so they call Vision, hey, could you please add a new node? So our team goes to the file that corresponds to that particular client. That file is versioned on GitLab, and they can submit a merge request on GitLab or a pull request on GitHub. And somebody else from the team is going to check that out just to make sure that the networking parameters are correct, that the security rules are respected, and so on. And then that person will click merge. That goes into, let's say, the main branch, and that triggers a pipeline that will ultimately deploy the application. So all in all, after a few minutes, your infrastructure is literally the representation of whatever you have written on those files. So this is GitOps. The teams, the operations teams, the only thing they need to do is to use the same workflows as the development team, because developers store everything in Git. So now operations teams also store everything in Git, and we have GitOps. Of course, we are now on the world of DevSecOps, or maybe it's DevGitSecOps or DevSecGitOps. It depends on how you put it. We all agree that Dev comes first and Ops come at the end. So in the middle, you've got Git and you get security. So that's a good thing. How do the three principles of DevOps apply to the world of DevSecOps? Well, first of all, the principle of flow. Thanks to the principle of flow, security teams can proactively harden the security of apps. Every time they are notified on the press, for example, that some new threat is available, it's breaking havoc somewhere on the network, basically they can go and proactively add new rules. And this way, your application becomes more secure as time goes by. Thanks to the principle of feedback, we can keep an eye open on threats. And for example, we can see that somebody is scanning the ports of our infrastructure and take that as a feedback and flow more features to harden the security of our platform. And thanks to continual learning and experimentation, even if things go wrong, which sometimes happens, we have a culture that allows us to write postmortems, to meet for an internal education, and try to figure out what we did wrong, how we can prevent this from happening ever again in the future, and incorporate all of that as feedback on the system. And this way we can get more and more security as time goes by. So now to the gist of tonight's presentation, which is undoubtedly NGINX App Protect. It's a tool that fits perfectly well in the scenario that I just described. It allows developers and operation teams to increase the security of their applications running on the cloud, not even needing to modify the source code of those applications, which is particularly interesting, for example, for legacy applications that have to be running because the business requires them. Here is a method for operations teams to intervene and to protect the security of the whole infrastructure using one very, very incredible tool. App Protect has incredible advantages. First of all, is fast. Really, really, really fast. We are going to talk about that in a minute. Second of all, off the box, you install it, and there's a long list of attack vectors, an incredible amount of security brought directly to your infrastructure with one operation. And this is awesome. It works very well in containers, which makes it perfect for Kubernetes. And Kubernetes is becoming the standard deployment platform of the world. So it's very, very important that we have this compatibility. And there is App Protect is not all alone. Thanks to the ingress controller, the NGINX ingress controller, also provided by F5, allows App Protect to be integrated and activated automatically so that it discovers the routes that are available on your Kubernetes cluster and automatically have WAF rules applied on them. And this is incredibly simple and very fun. We're going to see that in the demo in a few minutes. And this means that we actually have security as code. We are going to add more infrastructure information, not in the form of Terraform files, which is what I just shown, but typically as classic YAML files for your Kubernetes installation. We're going to see that App Protect uses exactly the same formats that you see pretty much all over the web for Kubernetes objects, which is in the form of YAML files. So this is very standard and very easy to integrate, and it reuses the knowledge of DevOps teams all over the world. And of course, NGINX is uber popular with engineers. So it's we all know in the medium that it's a very fast technology, and this builds on top of a very solid background, which is NGINX itself, of course. Speaking about high performance, don't take our word or F5. Actually, there's a report by GigaOM that is available on the NGINX website. You can check it out. You can download it. There's an incredible amount of information about how fast this is. And on the tests performed by GigaOM, which are described as well, you can see a higher performance than mod security or the Amazon web application firewall. So all of this shows that there's a lot of work done so that the security won't have an impact on your day-to-day business. You can keep on doing, your users are going to have a very similar experience to what they have now, but with much increased security for your own infrastructure. In terms of attack vectors, NGINX App Protect comes off the box with a huge amount of different solutions, up to more than 40 different attack types, starting with the classic one, like the brute force or the buffer overflow, the parser attacks on JSON and XML. You also have protection against XSS, cross-site scripting, and SQL injection and NoSQL injection. Seriously, pretty much all of the common issues that you have with cloud native applications, you can solve them off the box. And if that is not enough, the NGINX teams provides regular updates. So if you're installing manually App Protect, you can install on CentOS, Red Hat Enterprise Linux, Debian, Ubuntu, Alpine, and many other. You can install a package called App Protect attached signatures. And this package is updated regularly by the NGINX security team, depending on the circumstances and on what they learn about the network. They keep an eye as well. So this is an added value that is really, really interesting for companies because you get this literally with the same subscription. You just update your system and you get new knowledge. Your system becomes smarter and can protect itself much easier. So this is great. Not only that, but NGINX plus App Protect is available with one-click installation from the marketplaces of Amazon, Microsoft Azure, Google Cloud. There's even an operator for OpenShift, for Red Hat OpenShift. So seriously, lots of different options for you to get your Kubernetes clusters to be protected by NGINX App Protect. However, the important thing is to see how all of these things go together, right? So basically what I'm gonna do tonight is to deploy an insecure application on Kubernetes. We have this old app. Basically, we don't have the source code anymore, but we have to run it because our customers like it a lot and our business depends on it. We are making tons of money out of this. So basically, we cannot get rid of this. But actually, it has a lot of security problems, and we're going to see that in a minute. So what we're going to do is to install NGINX App Protect with the NGINX ingress controller on our cluster, so that basically we are going to increase the security of a whole setup, and we're going to see that it actually works. And we are going to identify a new threat, but I'm not going to say anything else right now. I'm just going to leave you with the incognita, and then we're going to see exactly what kind of threat we're talking about right here. So now what I'm going to do, I'm going to go out from full screen right here, take a sip of water. There we go. So I have here my Exascale console, as you can see on the screen. I've created a very simple scalable Kubernetes service provided by Exascale, a simple cluster that basically at the moment contains absolutely nothing. It's completely empty, it's completely virgin. Not only that, I've created a small GitLab project. We're going to make this GitLab project available at the end of the presentation on the Vision account. Right now, I'm using my personal account for reasons. And the important thing to know right here is that I've configured the Kubernetes parameters of my GitLab account. So Kubernetes right here, if I click on it, I can see my Exascale configuration. So if I click on it, I can see all of the configuration with the certificate, the service token, and everything that I need, so that this GitLab repository talks to my Kubernetes cluster. Very good. And I've also created something very simple in this project. For the moment, there's nothing. It's completely empty. There's a README. You should always have a README in your project. But I have a GitLab CI YML. And this GitLab CI YML couldn't be simpler. The only thing it does is that every time somebody pushes to master, which will be me, of course, in this case, I am going to apply all of the YAML that is on the deployment folder. It's a very simple setup. So that means that every time that I will commit a file to GitLab and I will push it to this repository on the deployment folder, it will be applied on the cluster. Very simple setup. Of course, GitLab CI is a world of its own. We've got a video on vision.tv about integrating GitLab and Kubernetes if you're interested, but this is not the subject right now. We're using a minimal setup. We have a very simple bare bones Kubernetes cluster on Exascale, and we've got a GitLab repository that is basically configured to be able to talk to our cluster. That's what we're going to do here. Very good. And of course, we've got the CI/CD tab where we can see the execution of our CI/CD pipelines. For the moment, nothing has been executed. This is a really, really, really new project. So here, what I'm going to do is to basically show you that this is live. So if I have an alias called K that basically it's an alias to kubectl kubeconfig demo kubeconfig. So I have a file demo kubeconfig. Of course, this kubeconfig file contains all the security information that allows me to talk to my cluster. So I can do, for example, k get nodes. And I see that these are exactly the same nodes, the same instances that I have on my Exascale account. So if I see ASEYI, and so on. So we are live. This is what's going on here. And here I can do as well k get pods. And basically I don't have anything. This is free of everything. So what do we have here? Again, the same setup as we've seen on previously. It's a clone of the project. So basically I can start working here. So the first thing I'm going to do is to, of course, I'm going to cheat. I'm going to use files that are already done. And I'm going to copy this into deployment. So I have a new file into deployment. And if I take a look at this file, it's a very simple file that deploys my unsecure Fortune application. This is an actual application. This is an actual container that you can actually go and pull it and run it if you want. It's a very funny application that I've created for this demo. And it exposes something on port 9090. And then I have a service. And this will create an exascale load balancer on my infrastructure. Very good. So right now, I can go back here. I can git commit. First of all, git add. I have a new file, git commit, added application. And now I push these changes to my GitLab. And if I go to the GitLab tab, I will see that immediately my push has triggered a new pipeline that is waiting. There we go. Now it is running. And if I click on it, I can see the details of what is happening. So basically it uses one of the shared runners provided by GitLab. And of course I could be doing this application of these YAML files directly on the command line. Okay, this is clear that I could do. But here I'm trying to show a common workflow that uses GitLab. And basically, this is much better for working as a team because all team members can share the same infrastructure and the same things. And here we can see that the job succeeded. This is great. I have a pipeline that passed. This is always very good news. And look at that. Look at that. I have on the bottom, I'm using an application called K9S, which is a command line Kubernetes console, and I can see my Fortune pods. And I don't know if you remember, but we've got 4 replicas of our pod in the declaration of our application. And of course, we have here all of the pods are running. So this is great. So now what we need to do is the following. I'm going to basically try to use this application and see what's going on because it's not really working well. So I'm going to execute a command that allows me to see the IP address of my Fortune service, and I'm going to basically copy that on my and now I can execute. And if you want, if you're watching this live, you can go to this IP address right now. You should be able to see exactly what I see here. So it's the Fortune cookie of the day. It's an application that's bringing millions to our company. So we really, really need this to work every day, you know. And here people can enter their names. Of course, I can enter my name and send, and boom, there we go. You've got this Fortune cookie for you. And I can refresh this page. I get a new one always for me. And as we can see, we've got this thing going on, right? The text that I put here appears right there. This doesn't look good because if I, for example, select, you know, some JavaScript, I could send it and boom, my page is yellow. This is not good. This is not good because people could be stealing my cookies. And now I can do an alert, boom, and boom, it alerts. And there we go. We've got this alert box that comes up. This is very, very, very bad. It should be easy to solve, actually. we could actually do stuff like select all from customers here, and I could run this, and I could do a SQL injection as well. And this is actually not very, very good. So clearly we have problems. However, we don't have the source code for this container. It's basically there. We cannot do much. So this requires the help of NGINX App Protect. So this is what we're going to do now. Good. So I go back to my command line, and basically the first thing that I need to do to use NGINX App Protect is to install the ingress operator. So the ingress operator, it's a series of YAML files provided by NGINX. So I'm basically going to apply all of these directly on my cluster. You can find more about this on the documentation. I'm not going to go step by step what's going on here. There's a lot of infrastructure, but basically this is what it does. So I'm just going to run this command, install ingressoperator.sh. And this will basically create a couple of objects on my cluster. You can get all of the information about exactly which files. All of it is in the App Protect documentation on f5.com. So please go check it out. I'm just summarizing everything in a short amount of time. The second thing that I need to do is to go to, what I did is to go to this page, and I went to nginx.com, and I got a free trial for NGINX Plus and NGINX App Protect. So you can go to nginx.com/free trial request, and you receive an email, and that email gives you the possibility of downloading 2 files. One file is named, let me remember, I don't remember the names exactly. There goes, nginx-repo.crt and nginx-repo.key. So this is a certificate and a key that certify that you are a customer from NGINX. And using that information, the next thing you need to do is to create the custom ingress container image. So basically, the thing is as follows. You've got the ingress operator, but you need also the ingress controller. And the ingress controller image, you can basically follow the steps here on the screen. You have to clone one project provided by F5, and then copy the files that you got from the free trial request website, and then in this case, I chose to create a Debian image based on those parameters, but there's plenty of options. And of course, the important thing is that I'm using the NAP Plus option. So I'm adding the NGINX Plus and the NGINX App Protect components into that image. So my ingress controller actually will contain all of those modules already integrated. And because I'm copying my own CRT and key files, NGINX can verify that I'm a customer, my license is valid, and things go on. So this is the first thing I need to do. The second thing I need to do for my custom ingress controller is to use it. So basically, this is what I've done, and I'm going to show you. I have, of course, my controller ready. So if I show it, you can see that here it is an NGINX ingress controller. And basically, it uses an image that I pushed to quay.io, which is an image repository, just like Docker Hub. I'm using this one. If you use it, of course, the license will last only 30 days. But the important thing to know is that I'm using an open repository, so I don't have to configure the pull request token in my Kubernetes cluster. It simplifies my setup. Of course, in your case, you want to keep your NGINX key and certificate private. You're not going to do this. You're going to have to configure your Kubernetes cluster with the required pull secret so that it can go get the image and put it into production. Very good. So this is the setup that I have. Very simple one. So let's continue with our operations. So right now, what I need to do is add the new file, add a nice comment here saying added NGINX controller, ingress controller, and push. And this will trigger, of course, a new pipeline on my cluster. If my git push works. Yeah, it did work. And now my pipeline should update itself. There we go. It's pending, waiting for a cluster, waiting for a GitLab worker to pick up this job and execute it. So let's see if that happens. There we go. We've got our pipeline running. I can click and see the details and see how it goes. Let's leave it running because we all know that this is going to work. And now we can see that things are starting to take shape little by little. We have now our, there we go. So if I look here in the bottom, I can see my NGINX ingress controller that is starting, it's container creating. So it's getting a copy, it's pulling the image from quay.io. It's doing everything that it needs to do, and it's running. This is really, really cool. Very good. So now we have our NGINX controller ready to go. And now the thing that I need to do is to get the IP of this new controller, because this controller is basically of type load balancer. So I have a load balancer on Exascale that is ready to use, and I can use this command. And this is the IP that I need in this case. I'm going to do something as well that is, I'm going to do it later. For a moment, let's leave it like that. I'm just going to export this IP address onto a variable, and I can see it's the same variable, and that's all well. Now I need to do a few more things to install my NGINX App Protect. I'm going to copy a few files from final deployment. I need a syslog image into deployment. I need a configuration for my log and a secret as well. And I'm going to explain why in a minute. Very good. So I've got these 3 new files that I'm just going to commit. There we go. So let's see how this goes. Once again, if I go to my CI/CD pipelines, we see that there's a new job. Every time you push, there's a new job starting on your GitLab, which is exactly what we want. There we go. It is running. Let's see the details. And after a few seconds, we're going to see new pods running on our infrastructure. So as you can see here, I have right now on my cluster, we have the ingress operator, which I installed using the scripts. We've got the ingress controller that I just installed using a custom image built with my NGINX key and certificate. And now I have a syslog component. This component is an instance, it's a pod with the container Balabit syslog ng. It's basically an implementation of the syslog protocol, and we can have logs running inside of our cluster very simply. And then I'm going to use this later on to show you how it works. Very good. So having done all of this, now I need to find out the internal IP, the cluster IP of my syslog pod right here. So here I have an IP that I don't know if it's a good one. I'm going to type this command. Let's see the syslog svc and see what is the cluster IP. So basically, I can do the following. Here I can see all of my services, and I see syslog IP. The cluster IP is 10.108.152.65. Very good. So I suppose that this is what I got on my clipboard. This is exactly what I just got. That's really, really cool. So now I need to do something. I need to configure my ingress. So the ingress controller requires a little bit of configuration to know what route to follow and what to display in that route. So of course, for that, I'm going to go once again to my final deployment, and I have this ingress that I'm going to copy inside of deployment. And I'm going to edit that ingress configuration because I need to do an operation by hand, which is to change the IP of my syslog server, which is the IP that I have right now on the clipboard. So this is exactly what I need to have right now. And just to show you what's going on, NGINX, the NGINX ingress controller requires TLS information in order to work properly. So I need to provide a host name. In this case, I chose the host name NGINX vision.info and a secret name, the secret name Fortune Secret, which is the secret we just installed in the previous step. It contains the TLS certificate, just a very homemade security pattern, but it works pretty well. And of course, we are going to have some rules in our ingress. Our host, NGINX vision.info, will serve at the root the contents of the Fortune service on port 80. So this is exactly the configuration that we want. We want all of the calls going to NGINX Vision Info to be routed inside of the Fortune service. Very simple configuration. Let's save this. Of course, this change that I've made here, it's in such a way so that the ingress controller can report on the syslog pod all of the security breaches that it detects. This is exactly the reason we are doing this. So GST, git status, new file, git add new file, git commit added ingress routes and push. So these basically will send all of this information. Now, I don't have the domain nginx-vision.info configured on anywhere. Actually, I don't know if the domain even exists. I guess not. So basically, what I'm going to do right now is to configure the host file of my machine to be able to use that same IP. No, exactly. That's not the good one because this is a cluster IP. This is a cluster IP in our Kubernetes cluster, so it doesn't make any sense. I need the actual IP being exposed by the cluster, and we've done that a few minutes ago, which is echo IP other. So it's this guy that I need, PB copy. I'm going to copy this on my clipboard, and now yes, I can do the following. And now the NGINX Vision Info entry, whenever I type that on my browser, I should be taken to this IP address. And this is required by NGINX App Protect, because one of the first things NGINX App Protect does is to see if the request actually belongs to the domain being served. This is one of the basic rules of security, and this is something that is required by NGINX App Protect. So that's why we have to cheat a little bit. Of course, in your case, you might have a real domain, which is even much better, but I didn't want to buy just the domain for this thing, and this trick works pretty well. This means that I can go now to my domain. As you can see, it's not yet ready. It's still doing things internally. All of the pipelines have passed, which is really good. I will go back here on my screen, and I see now that my ingress controller has that IP. That's really good. That's perfect. Let's see. After a few seconds, sometimes it takes a little bit to activate. And of course, what I'm doing here is absolutely ridiculous. I actually forgot that what I have to do is to use the NGINX Vision Info domain. That's what I need to do. Of course, there's a little bit of security. There we go. That's exactly what I need to do, is to go to the domain that I have configured, not the IP. But see how interesting. If I send a request to the IP, NGINX App Protect will say, no, this is a request for an IP. I'm serving a domain, so you have to send the proper domain. So basically, this is the first check, and you've seen it live right now. And here, if I look at my application now, I can still use it. So I can get good fortune for myself, but I cannot get a request with an alert, for example. I cannot get a request with SQL. That's really cool. There we go. So this is actually still running right here. So if I go to this old IP, this is the old IP, this is the old load balancer we started at the beginning of the session, that it's still available. These are the same pods, the difference being that this particular route is being exposed and protected by NGINX App Protect. So here you have the same pods who are exposed through two different load balancers. One of them is protected, the other not, and you can see the difference here on the screen. Very simple. If I try to do alert boom, etc., and so on. Now, I can actually try something, because I can try something like, look at this. This is terrible. My application is vulnerable to the Smurf attack. So I don't know if the NGINX engineers know about this, but this is a new kind of attack that just appeared. And basically, you know, Smurfs, the Smurfs are very, very interesting things. Let me tell you a little bit about the Smurfs. So Smurfs started getting into hacking lately, and we don't really assess all the damage that they can cause, because, you know, particularly Clumsy Smurf, when Clumsy Smurf gets the keyboard, you know that things are going to go south, and they are getting much, much better. There are actual schools of Smurfs teaching each other hacking. So here we can see a picture which has been declassified by CIA for this presentation, which shows this in action. This is very, very, very bad. And we have to do something against it. Now, the good thing is that on one side, I don't want to take down my application, reconfigure all over the place. One of the great things about NGINX App Protect is that I can change the configuration of the signatures of the requests that I'm receiving in real time. So basically, I can just push a new rule to my cluster, and NGINX will reconfigure itself to block requests with Smurfs. So this is what I need. I need to create a custom signature. So a custom signature, in this case, is just YAML. As you can see, it's an object of type AP user sig. And in this case, I'm basically specifying that every time you receive a request with Smurf on it, it has to be blocked, and it will be logged as other application activity. This is exactly what we want. So let's create one of these guys. I'm going back to my terminal. I'm going to clean a little bit here. I'm going to copy another file because I'm cheating all the time. And I'm going to put that into deployment, of course. And here we can see the file is exactly what I just shown on the screen. This part is exactly the same. There's a little bit of configuration as well that comes here in the bottom that basically specifies the filters that we want to apply. So here I'm explicitly saying, please apply the signature set for the Smurfs. So this is exactly everything that we need at this step. So I'm going to, once again, git commit added. So git add first. Git commit added protection against Smurfs. And this, once again, will trigger a new pipeline on my cluster. The cluster, once the pipeline is finished, will talk with my Kubernetes cluster on Exascale. This will take a few seconds. And the Kubernetes cluster, once it receives this information, the NGINX App Protect module running right now inside of the NGINX Ingress controller will detect this new signature and will basically reapply and reconfigure itself without me needing to do anything else. So let's wait for a few seconds. Let's see how this goes. Very good. This is great. The pipeline executed successfully. Everything is working, and this is great. There we go. Pipeline has passed. So now basically I can go now to my demo once again. And no, I can keep on trying to be Smurfed. So let's refresh this Smurf thing. It will take a few seconds to activate itself. For the moment, NGINX is reading all of this new configuration going on. I can show that this configuration is available by looking at the app policies on my Kubernetes cluster. So I can see that there's a Smurf signature with a Smurf tag, and that a few seconds ago, there was an update of the App Protect policy. This is really, really cool. I can see that user signature called Smurfs. It exists on my cluster, and I can actually go and take a look at it. And I see that my cluster has the information to block all of the configuration. So it can take a little bit of time until you get the configuration that you want. And there we go. I refresh the page, and now no Smurf can use my application ever again, not even Smurfed. Smurfed being the only female member of the family of the Smurfs, or even Papa Smurf, who, as wise and as intelligent and as old as he is, we don't want him to use this application in any case. So there we go. That was basically what I had for you today. If you want to learn more about how to use App Protect, there's an incredible amount of documentation on docs.nginx.com. Please check it out. I've included the link to our page on the vision.ch website, where we show everything that we do with NGINX. And if you need any information about any help with NGINX, we at Vision will be more than happy to help you in. And I've added as well a link to the OWASP top 10 risks, so that you get a little bit of information as well of one of the subset of things that NGINX App Protect can help you with. So that was everything that I had for you today. If you want a copy of the slides, write down the link bit.ly/nginx-app-protect-devops. So if you type down that, and I will leave this slide anyway on the screen for the time being, you can get a copy of the slides right away, so you don't miss anything. We're going to make the project that I just built available as well on the GitLab Vision account, so you can try it out. And of course, there you go. There's my email. Please shoot me an email if you have any inquiries, any ideas, any doubts about what can be done with NGINX, NGINX App Protect, the ingress controller. We use these technologies all the time, and we love them. So please stay in touch. Get in touch with us. And yeah, and of course, I'm more than happy to answer any of your questions right away. So I don't know if there are any. Let's check it out. There's in the chat. There we go. So yes, as Arno said, we'll send you the links via email later as well. Are there any questions about NGINX, Kubernetes, GitLab, and everything that we've shown today? And I thank the demo gods that this time have been very good to us, and we've got a funny presentation to show. There we go. So let's see if there are any questions. Please feel free to write them down on the Q&A box that is available at the bottom of the Zoom screen. And I take this opportunity to take a sip of water. So we have a first question here on the chat, which is, how can you handle false positives? Is there an automated tooling? I actually don't know that precise thing. It's actually that I never asked myself. So I don't know if maybe Mario, who is here as well, maybe he can jump in, or somebody from the NGINX team who might be in the audience. Please raise your hands and let me know.
So hi there. Thanks,
Here's
Adrian,
Mario.
again for a great presentation. Just
Thank
to
you.
jump in there, so there's no automatic tooling available, but with the IDs that you've seen for every wrong request, you're pretty fast on finding the needle in the haystack with the bug IDs, or pretty much the IDs of the errors. Then you can pretty much drill down and find the errors pretty fast.
Excellent. Thanks, Mario. I hope that answers your question, Martin. I hope so. Some other questions? I usually wait for a few seconds because people are sometimes writing their questions and I don't want to block them. But apparently, oh, okay. So Martin is asking once again, the filtering for all protected services occurs on the ingress controller, right? Mario?
Yes.
The
answer is yes.
Perfect. Good. Well, in that case, if there are no more questions, please feel free to write down my email. Shoot me an email if you have any questions, if you need any help. If you need a personalized demo of everything we've seen today, we're more than happy to help you with your installation of NGINX App Protect. And in general, any NGINX F5 project, of course. And thank you so much. You've been a great audience. It's sad that we cannot meet in person. We're going to do that very, very soon, I'm sure. And thank you so much for this, for attending this presentation, and see you soon, everybody. Bye-bye.